Tanette Peters, who's leading the model lesson. My part is like the opening show. Because we're gonna do sort of like an opening, like set the stage, here's what's going on, here's what you need to know about the lesson. Then she's going to lead the full 90-minute lesson, and then as a group, we're gonna like engage in a reflection. So this is like a 2-hour block of time that we're gonna be working together and really doing the work. I'm really excited. It is a blended learning session, but you don't need your laptops right now. You will need a writing utensil. You definitely need your named tent. And you're going to need the Algebra 1 handout, and that's why I really need Tanette before I start passing out things at the wrong time, in the wrong way. I'm just going to wait till she comes back. So that, every time the door opens, I'm like, Tanette, no. Okay. All right. So, math team norms, same 5 from before. The one I really want everybody to focus in on during this block of time is be purposeful with the time that we have and remain fully engaged, especially during the model lesson. Here's what I'm going to ask. It's an Algebra 1 model lesson. And for some of you, you're like, I teach pre-calculus, or Mr. DeRozier was my AP calculus teacher, like, once a week, you know. I already know so much. I'm gonna ask you to suspend all of that advanced content knowledge and really stay focused on what would this experience be like for a 9th grader who is in Algebra 1 learning the content for the first time. Everybody okay? I want you to turn to somebody near you and pinky promise you are gonna stay in good student mode. I am not asking for you to act like your 9th grade self. You're like, oh, he doesn't know what I was like back then. No. Okay. Session outcomes, we have 3. You're going to describe academic routines and procedures that maximize instructional time and lead to student learning. Even better than describe, I would replace that verb with experience. Tanette is going to lead this session, when she comes back, as though you were her students. You're going to engage with the model student work exemplar and create or revise your own. So you're going to do the student work, when you have the handout, as a student would, which is your first pass at preparing the lesson. And then as we get into the lesson cycle experience later this afternoon, you're gonna start layering on and like really get into the preparation process. So by the end of the day today, you have your student work exemplar. You're also gonna identify the supports that are embedded in the lesson to support students in special populations. Oh, thank goodness. If you could pass out the handout, I didn't want to mess with the handout.
Yeah.
Oh, that's right. Kid Sister's supposed to take care of that. Thank you, Kid Sister. All right, so come on. Come on. All right, so you're going to internalize the priorities for Algebra 1 beginning of the school year that are going to show up in the model lesson. This is a lesson that is coming from the first couple of days. So you're going to see Tanette set those expectations. You're going to participate as a student in the model lesson. You're going to create and revise your teacher exemplar. And then you're going to reflect on the experience that you had as a student and how the lesson internalization facilitation led to student learning. That's what we're going to do. You are going to get a chance to see the 5E instructional model happen. It's going to start with an engage, and I know, if I know one thing about Tanette Peters, she is engaging. She brings her full self to all of her lessons. There's going to be an explore, an explain, an elaborate, and an evaluate. And what you're going to see in each of these 5 pieces is that student expectations, in terms of like behavior and routines, those aren't going to change. But like what students are doing, how they're doing it, who's doing the heavy lifting, you're gonna see this shift. And so you're gonna see it, we're gonna talk about it, we're gonna stamp it at different times of the lesson. So Tanette is gonna get us started in just a little bit. In terms of instructional priorities, I want you to keep in mind that we are focusing on implementation of the curricular resources. You're going to see and experience some student discourse and writing. You may or may not get an assessment, and I bet what you're going to see is Tanette even doing some data-driven instruction based on even informal data. As she circulates through the room, what is she seeing? What's she seeing at this table? What misconceptions are coming up? How does she respond to those things? I want you to try to be in student mode, but also have part of your brain in teacher mode and go, oh, that's a move. I want to put that one in my pocket today. What clarifying questions are out there? Okay, so a little context to frame the lesson. The course that this lesson comes from is Algebra 1, 8th grade, Algebra 1, 9th grade. The unit is linear equations and inequalities. The specific objectives, so the skills you're going to work on today, are determining solutions that make an inequality true. Remember, 8th grade, 9th grade. Okay? So determine the solutions that make an inequality true. Write inequalities for both mathematical and real-world situations, right? We were talking about those real-world connections. We are always going to be pushing the real-world connections. It's not just, oh, I can solve an inequality. Why do we care about solving an inequality? What does that solution represent? And then you're going to graph the solution set of inequalities. I'm just going to read this next part. At this point in the unit, students have learned how to solve simple equations, multi-step equations, so maybe there's a subtraction step and a division step. Maybe there's a distribution step. Literal equations, that's F equals MA. You've got multiple variables going on and it's not just solve for X. They've also done some writing equations for mathematical and real-world context. Students are then going to transfer their prior knowledge of writing equations to writing inequalities, right? The big difference is going to be some of the vocabulary. We'll see less than, at most, greater than, no more than. Students have been exposed to solving inequalities in Math 8, but what that means is if I'm an Algebra 1 8th grader, this could potentially be a gap for me because I haven't taken the Math 8 curriculum. I jumped from Math 7 because I did really, really well in Math 7 up to Algebra 1 as an 8th grader. Now, normally those students are successful with that leap and they're going to be okay, but there is going to be a little bit of backfilling that might be necessary for that group. Okay? All right. Two perspectives that I want you to have is I want you to think, what would it feel like to be a student in Tanette Peters' classroom? And then secondly, how can I learn from this for my own instruction? So you're TE, you're in New to Blue, you're an instructional coach, an instructional leader. Okay, I want you to do a quick think, pair, share. What does it mean to be an effective participant in this model? Take 10 seconds to just think. What is it going to take for you to be effective as a participant in this model? If you get an answer, just put a little finger up. 1, 2, 3, 4, 5. Quick whip around at the table. And let's start with the tallest person at the table, clockwise. This is actually your work. We're going to wrap up the conversation in about 30 seconds. Yeah. The guy that was
teacher, the biggest not related to their master's, so someone from us.
That's great to hear, because there are some things here that we don't usually in our district. I'll be ready to support this. I'll give it.
All right, if I could get 3 people, 1 from Michelle's table, 1 from Joelle's table, and 1 from Shane's table. Let's start over here at Michelle's table. One of you, what is it going to mean for you to be an effective participant?
We said to be an effective participant, we want to be engaged, like in her lesson, and internalize like the way she's teaching the lesson, but also see what things we can implement within our classroom. And even if there's things that we don't agree with, like maybe how can we cater it to like our own teaching stuff and kind of still like everything will still be useful regardless.
Absolutely. Well done. Joelle's table.
We pretty much just agreed on, similarly, recognizing the creative ways that you present the material, but also if we're acting as students, recognizing what it feels like to have that material presented, as a student, and using that to then say, okay, well, how can I, make it different for maybe an older, like a 10th grader, 11th grader, or things like that.
Excellent. Thank you for that, Joelle. Shane, or Shane's table. You deputize somebody.
I want to focus a lot on the classroom management behaviors, both as a teacher and as from like a student end. Mostly on like how to keep students focused so that they don't lose concentration and maybe not work their math problems out.
Okay. That's a tall order. I think you've got that. And at this point, I'm going to hand it over to.
All right, so, okay, good morning, everybody. I am super excited to do the model lesson. Just a few things for you all to note. So we will transition to like the DotCam once I go through a few things. I don't use PowerPoint because I'm too small. That's just really reality. I can't reach up there. I tried it, it doesn't work. So I use the document camera because I'm so itty bitty. I am also like super like loud, fun, very energetic, and so here's the thing, you don't need to know Algebra 1, that's not important, that's the point of the lesson, you're gonna learn it today. Just like be an active participant and just be excited and be ready to learn and engage with your table, okay? So, next slide. Okay. All right, so, good morning, my lovely students. So, happy Wednesday. What you all need on the board, we should have our laptops out. They should be charged. Right now, we don't need them, so you can have mask them or you can have them closed 100%. Everybody should have a writing tool. Does everybody have something to write with? All right, great. Everyone should have a copy of the lesson notes 1.3.1, writing and graphing inequalities, right? Hold it up if you have a copy. Go ahead and hold it up. Thank you so much. All right, almost at 100%. Perfect. All right, almost. There you go. All right, thank you. And then we will have our supplemental aid. We'll have the calculators if we need it, but not so much. All right. Up here, we'll see a snippet of where we will be going today when we get to Schoology. You'll see the folder, of course, in Unit 1, linear equations and inequalities, will be in the 1.3.1 folder, okay? So when it's time for the exit ticket, that's where we are going to go.
And tonight, if you need, I have calculators.
Well, okay, I need it. This lesson is going to be lesson 1.3.1, and we are writing and graphing inequalities. We have 3 objectives up here. Can I get somebody to read this, to volunteer, raise a silent hand to volunteer to read this? Yes, ma'am, go ahead.
All right, students will be able to determine the solution that make an inequality true.
Perfect, thank you. Can I get somebody else? Go ahead, thank you.
Students will be able to write inequalities for both mathematical and real-world situations.
Thank you, and that went too fast. And then we have one more. Can I get somebody to read this one? Yes.
Our students will be able to graph the solution set of inequalities.
Okay, perfect. So as you see up here, we have 3 objectives, and I have these words that have these circles around them, right? When we look at the objective, these are the things that should stand out to us. Inequality, because that's what we're dealing with, right? We've already dealt with equations. We've solved those nice long equations with the multi-steps and everything. We're not doing that today, okay? We're gonna have the same process, but we're going to transition to inequalities, okay? Then, there are two big things, right? We're not even solving. We've been solving equations for about 5 days now. We're not solving equations or we're not solving inequalities. What we are really focused on here is writing the inequalities and then graphing the inequalities on a number line, okay? So we have two big things that we should be able to do today. One should be right and one should be graph. What are the two things we should be able to do by the end of today? Right and graph. Y'all are so great. My sister right there, can you go ahead and give every table a point? Thank you so much. Everybody is getting some points. I know y'all wanna go on a big trip. I know y'all wanna go and win those things. So now we're gonna transition. I'm gonna pull up the notes and hopefully you all will be able to see my screen. Yep, all right. So we're gonna do this as best as we can until Keith DeRozier gets back here. So for the first part of the engage, I'm going to put this up here and I'll just actually make it bigger because the only thing you need to focus on right now is just like number one, since you don't have the paper in front of you, okay? So you have two inequalities here, right? What you are going to do is write down 3 values that make the inequality true. I don't know what that means. Do you know what it means? Who knows? Compare the values. After that, you're gonna compare the values with your group and find the similarities between them. And then we're gonna graph all the values from your group on the number line, okay? So right now you have 4 minutes to work on the engaged portion independently, okay? 4 minutes to work on the engaged portion independently. Thank you to my table here for getting started. Thank you to my front table, table 1, for getting started. Thank you to everybody who took out a sheet of paper and there's this drawing, this nice number line. Y'all are so great and flexible. So we should be thinking about what are 3 values that make this inequality true? Two more minutes. One more minute. Almost there. And remember, everybody should have 3 solutions that makes that inequality true. 3 solutions. Alright, give me, now, is there anybody who's still working, who doesn't have a solution? I think we're. Okay, perfect. So now what you're gonna do, you are going to work with your partner. I see 2 partners here. There are 2 partners here. Everybody should have a partner. Get in pairs of 2. You all will have a triad somewhere, and then you all will continue to and remain in groups of 3. So you're gonna work with your partner, and you are going to compare your values, and then you are going to answer these questions. What are the differences and similarities between the 2 inequalities that we see, as well as, right? Jasmine said that the possible values for y and 1a is 12. Do you agree or disagree with that? For your first inequality, Jasmine has stated that, hey, 12 is the solution. Do you agree or do you disagree, okay? So again, you're gonna take 3 minutes to work with your partners. You are going to compare your solutions. If you did not graph your inequality, graph it, and then answer these 2 questions. Any questions? Go.
Yeah, so I know that there was differences not. Jasmine at this point said it's impossible.
I put a closer look at
I disagree.
because the inequality symbol is less than or equal to.
So the smallest.
Show that or represent that it is equal to 3, I have to close this. So you knew one.
We're holding it.
We don't have to, but we would graph this.
Because it would be like numbers less than this, so everything on the number line. Also the
Been here even longer than me, so 14. What would she need to do with that inequality to make her answer correct?
the line
We disagree.
It makes so if I have to show greater than or equal to, or greater than or less than.
And so we know it doesn't have
Right, but I'll make it work.
So.
And then if it's greater than or equal to less than, it has to be split.
So it can be anything.
Oh, because that's what the value. Yes, ma'am.
And then we agree, do we agree with them or do we disagree?
Yeah.
Everybody?
We said we have to change her inequality to maintain.
Yeah, so that's no bueno right there. Okay, all right. I like
Her
that.
brain is working great.
All right, can I have you guys, eyes to the front in 3? I know we wanna transfer our knowledge on our paper, it's okay, eyes to the front in 2? I know, you just wanna keep on doing it. I like this, listen, table 1 over here, they're gonna get all of the points to go on the next bid trip for, 9th grade. Because they're doing what they're supposed to do. And then eyes to the front 1, thank y'all so much. So thank y'all for engaging in that. And so as I walked around, I saw some interesting things going around here. And so for the most part, most of us got the similar solutions. For this one, for part B, everybody had this one number. We can yell it out, what's the one number that everybody had as a solution for B?
3.
3, right? Everybody had 3 as a solution. Can somebody raise a silent hand and let me know why did everybody have 3 as a solution? Yes, ma'am?
Because the symbol we're working with, includes equal to, so it can be 3.
Thank you. Make sure you give table 6 back there for points. Thank you so much for volunteering. And then, so we identified the differences between the 2 inequalities are the inequality symbols, right? Now here, oh, Jasmine, right? Jasmine is working hard in Algebra 1, and she said that 12 is the solution to our first inequality, right? So I'm going to call on Miss, how do I pronounce it?
Joelle.
Oh, Joelle? Okay, sorry, I'm looking at the wrong thing. Okay, Miss Joelle, can you let me know why you and your table agreed or disagreed with Jasmine?
So we disagreed with Jasmine because for the first problem, it didn't have that half equal sign under it. So we knew that 12 couldn't be included.
Mm-hmm.
So it had to be everything above 12. But 12.
There we go.
But 12.
Good job. All right, so I just want to reiterate here. So she said this will have equal sign. We're just going to say, not mathematical terms right now. Right there's a line underneath this inequality symbol that lets us know that it is a part of the solution. So everybody said, hey, for part B, 3 is a part of the solution because we see this little line here, right? For the first one, we don't see that little line underneath. So 12 is no way that 12 can be a part of the solution. So thank you to everybody for engaging in that and great job. Now, I'm gonna pause and I'm gonna transition to the camera and you all can transition your work on your papers like you were doing. So give me about 2 minutes. Okay. Look at everybody working so diligently. I just really love that everybody's transferring their work from their papers Stu, their guided notes. Can we make sure that every table gets a point? Thank you so much, students. Oh, they're up there? Okay. Yes, okay, perfect. Oh, yeah. Does everybody have their work transferred to the notes? Okay, you can go ahead and turn to page 2. Haha, right here, page 2 for me. Okay, so now that we've learned, we've looked at the engage, right? Now we're gonna go ahead and we're gonna participate in the explore. So you are gonna work with a partner and you are gonna write an inequality for each statement. Right, there are 2 statements here. So for each one, you're gonna write an inequality, and then you're gonna sketch the graph of the numbers that make the inequality true, okay? So you and your graph, you and your partner, or your group, you're gonna work together to do that. You're gonna have 4 minutes, and then we're gonna come back and debrief whole group, okay? All right, go.
Oh, yeah.
All right, she listened to Math 8 and Math 6.
So it can't go above it, but it can.
I like that, okay, and then I like the fact that you have these 2 things coming around, that's what we transfer them to. You have very good.
A lot of math.
You have 2 minutes, 2 minutes.
I already saw the description where they would
It's the math schedule, so it's like, you have everyone's room, everyone's here. But I told my pastor, he was like,
All right, we're coming on about 1 minute. If you have not done part B, make sure you get to part B. If you have not done part B, make sure you get to part B.
So then my arrow would be on. So my
All right, very steady. All right, beautiful students, let's bring it back to the front in 3. All right, eyes to the front in 2. And then I see my lovely table here. Listen, table 3, they are very engaged. They said we are writing our inequalities, ma'am. Okay, we want to get points too. I appreciate you. All right, so as I was walking around, I saw some very interesting things, and then I heard some really good discussions. And so I took this from Miss Merriman. I took her paper and I'm gonna put it up here, and I want us to use this to be able to have this sort of kind of as an exemplar of what it is that we would have, right? So for our first statement, can somebody tell me what is it that you noticed that she did, her and her group? What did they do in these two? I'm gonna go here, then I'm gonna go here. Yes, sir.
Well, when she read, which is one of the things we teach our students, is to read and identify keywords. So she circled the one at least, and then she underlined the variable itself. So that helps in solving the problem.
Thank you so much. Table 6 get some points, and then yes, table 1.
Yeah.
But you said, listen, he took, he took everything, but that's okay, right? So what I want us to do is I want us to look at this problem, and so one of the things, and I'm totally gonna write on your paper, and it's totally gonna be okay. If it's not frozen, you'll just have a extra really nice paper. So when we look at this, right, a few things that stick out to us, and I think it was table 3 who was discussing like, okay, this means that at most, right? This means that I can't have more. It's not gonna go higher than this, or it won't go lower than that, right? One of the things that I want us to also always make sure that we are doing is make sure that we are circling that variable. Like, what is the variable in every problem that we get? And so here, she underlined it, that's okay. Circle your variable. So thank you to everybody who did not and they're circling their variable. There is a lag on here, and that's okay. There we go, circle your variable. Second thing, I always make sure that we underline those phrases. So what is the inequality phrase? And I didn't even introduce you or tell you what it was. Y'all knew because of prior knowledge, because you're smart cookies. So everybody knew at least, right? At least is the one thing that needed to be noted, and then at most, right? Those were the two key phrases in both of those problems. Then we have the numbers, right? We have these constants. What do we do with them? 10%, negative 10 degrees, and then 2,407. Now, one of the things I did not see on anyone's paper, I saw people write this. I want to put it down here. I'll put it here. I saw t is greater than or equal to negative 10. In Algebra 1, right now we're in high school, or we're in 8th grade. One of the big things is that you have to add your units, right? So I did not see many people actually add on their paper what the units were. So if you did not have that, make sure you add degrees Celsius, right? And then down here, for our second inequality, make sure you add your units, okay? So we had everything. We had a checkbox. We had our variables. We had our inequality written. We graphed it. Everybody graphed it perfectly. And then we just have to make sure we add our units. The last thing I want to touch on, and I'm going to ask, I think it's Miss Miss Hester back there, can you let me know, on her paper, when she graphed these, she had the audacity to use a closed circle. I don't know why she did that. But Miss Hester, can you let us know why did you use a closed circle?
Because the number is, included in the inequality as part of the solution set.
Perfect. Thank you so much, and table 2 gets a point. So remember, as we thought about that on the first page back in our engage, right? Remember, Jasmine was no bueno because she said that 12 was included, but remember, 12 was not included because we did not have that actual equal sign underneath it, okay? All right, so now let's go, and this is gonna bring us into key point number
Ms. Peters, we
1.
had a GT question over here from Luis. He said that elevation can't be negative infinity, so would you continue the inequality over to the left? Or would it stop at some point because the earth is only so, we had a GT question over here.
I think that is actually a very great question, and you are most likely and potentially correct. Here, for the sake of this, the importance is being able to graph it on the number line, right? So you would know that, and when we get to domain and range, and you have to write those things, thinking about realistically how that would work, that would make sense. But for the sake of this, you would just make sure that you have your graph and your direction going to the left. It's okay. But you are a smart cookie, so kudos to you for doing the elevation can be negative. That's okay. So shout out to the crews over there.
Below sea level.
So yeah, be below sea level.
You could go, but we're talking about Alabama.
Okay.
It's Alabama.
So it's Alabama, right? All right. So now let's go ahead. We're gonna move into key point number 1. And so we've been talking about this informally, but now formally, we know that an inequality is a mathematical sentence, right, that is going to compare two expressions, obviously, right? They're not equal to each other, right? And so when we are doing that, we have these symbols. So again, my smart cookies who use their prior knowledge, you are already using things that you knew from your previous grade levels to identify what were these phrases, right? That we gave you the phrases and you were able to translate that to the inequality symbol. So what are some words, can I get some people to like share out, what are some words that we would actually utilize for less than? The easiest, obviously one is what? Less than, because we're so smart, right? So less than is a phrase. Is there another common phrase that we hear very often when we're thinking about less than?
Diminished by.
Oh, you know what? He definitely in high school. Interesting. But I want us, and when we look at a lot of the phrases that we see are actually going to have fewer than. All right, now if you want to diminish and demolish, listen. I love it. All right. So now when we have this inequality symbol here, right, for greater than, obviously we all know, right? The key phrase that we see the most is greater than. And then one that typically is just gonna pop up the most, right? We said it's fewer than, and then when we get here, it's like it's more than. Yep, good job. Okay. Now we get to our lovely friends of less than or equal to, right? We have this nice line underneath it. So this is less than or equal to. Most of us know this, right? And then there were some key phrases on your papers and from the Explorer that let us know. Go ahead, Lena.
At most.
Good job, at most. And then there's one more that, you got it? I know, that's right, no more than. All right, y'all, so we have Alita next door, but we're gonna be the #1 Algebra 1 team on campus this year. All right, I like it. All right, so no more than. All right, so now we have our inequality symbols for less than. We have our key phrases. Have the key phrases for greater than, less than or equal to. Now let's go to greater than or equal to. So obviously, the key phrase here is greater than or equal to. Okay. And then, what was one of the words, phrases that we saw earlier in the Explorer? At least, good job. Okay, and then one more. Does anybody know? Yes, ma'am?
No less than.
All right, good job. No less than. So these are all of the key phrases that we are going to see. So as we matriculate through the lesson, if you get stuck on the key phrase, I want you to go back to page 2 and look at those key phrases to figure out which inequality symbol that matches, okay? All right, let's go ahead and turn the page. And I'm gonna give you your notes back so that like you can be a great student as well. All right, there we go. Okay, so for the first example, what we are going to do is we are going to practice writing inequalities, right? And so, as I look on my paper, right, for part A, this is what you all were exploring, this is what you were doing. For part A says, a number W minus 3.5 is less than or equal to -2. So, I have multiple colors. You don't need to have multiple colors, but I always have multiple colors, and that's okay. So, first thing I want us to do, I want us to put a circle around our variable. The variable here is W, right? And so, I know that the next thing I need to be looking for is going to be, if it pops up, is going to be the inequality, right? Or the key phrases. What's the key phrase here that lets us know what inequality we're going to use? Because y'all are so bright, and yeah, technology is no bueno. So, go ahead and put a box around less than or equal to. Technology is no bueno. Oh. You might just have to turn it off and turn it back on. Oh,
The projector. We have a little.
Oh yeah, she's tall
Everyone
enough.
tall enough? I don't know who's standing.
That's interesting, right?
It's not you, the projector's
Oh man, this is what happens, and then we'd be like, all right, we're behind pacing, but it's okay. I'll still be able to, I can speak it, and hopefully it pops on. So admin, yeah, duplicate. Oh, do I have to click H1? Or no, it should be connected. Oh, yeah.
Oh, you're the laptop.
This 137? Yeah. Whew. Yeah, you know, pro tip is to have a student that's gonna be tech, okay? Have a student that's gonna be tech, all right. All right, so, all of the things that are going wrong, it's okay. All right, so, let's go back to example 1, right? So, our first sentence statement is a number W minus 3.5 is less than or equal to -2. So first thing we did was we circled the variable, which is W. Then I put a box around the less than or equal to. That's our key phrase that lets us know what inequality symbol we're going to be using. Now, there are 2 other important things here. So there, in key vocab, right, there's a constant, we have constants. Those are numbers that don't have variables or anything attached to it, right? So the numbers that are by themselves, I just go ahead and circle those, and I'm gonna circle those in green here, because those are, they stand on their own. They stand on their own in this situation, right? Then we have some numbers that are tied to the actual variable. That I'm going to actually go ahead and just do a little squiggly line like this. Okay? A little squiggly line. Okay? So now, I'm gonna write my mathematical sentence here. We're gonna go from words to numbers and variables. So I have that W, right? It says a number W minus 3.5, minus means to subtract, right? Is going to be less than or equal to -2. Right? And again, you don't have to have all of the colors, but those are corresponding with the parts to the actual the sentence, okay? So now we're gonna try B, and we're gonna try B together, okay? So B, can I get somebody to read B for me?
3 is less than a number n plus 5.
Okay, perfect. So what's our variable here? All right, so let's go ahead and circle N. Great job. Okay. Now, what's our key phrases for inequality? Y'all are so bright, right? We have less than. Let's put a box around less than. And then, what's our number that stands on its own?
3.
That's a good one, right? So thinking about this, right? The variable plus that is gonna be our squiggly line, but 3 is here on its own. But then our actual little statement here, a number plus 5, okay? So now let's go ahead and write this. If we can write this, let's go left to right. The first thing we have is 3, so let's put 3. Is less than, which means I should have a less than, right? Inequality symbol. And then a number plus 5. How would we write a number plus 5? And plus 5, right? Ta-da! Perfect, right? So now we have an answer here. Does it seem like it's making a little sense? Okay, perfect. So now, this last one we're gonna do, and then you are gonna practice, do some CFUs. The last one we have is 0 is greater than or equal to twice the number x plus 1. Listen, do not fret, do not get stressed out when you have these very long phrases. Guess what? We are math bosses, so we're gonna figure it out. Here, first step. What's the first step? All right, baby, circle the variable. What's our variable? I know that's right. Good job. All right. Now we have our next step. What's our next step? Y'all are so bright. What's our inequality here? I know that's right. Greater than or equal to. Good job, you all. And then, what's the number that's standing by itself? 0. Ah, y'all got it this time. Good job. Good job. And our phrase, twice the number x plus 1. Right? I'm gonna put my little squiggly line underneath it. Right? Okay, perfect. So now let's think about it. Let's write this. Okay, so first thing we need to have is what? 0. All right. 0. And then what am I going to put next?
Greater than or equal to.
All right, greater than or equal to, right? There we go. And then I know we have a smart cookie that can tell me, how do you write twice a number x?
2x.
I know that's right. There we go. 2x. And then plus 1. Look at that, math bosses. We have done it. There we go. Do we have any questions on how to actually write our inequalities before you go to your practice? No? Isn't it? Okay, perfect. So now what you all, because of time, you're gonna have 2 minutes, and I want you all to specifically do B and C specifically. So you're gonna do B, and you're gonna do C, and you're gonna have 2 minutes to do that. You're gonna do that one independently. Okay, you go. 2 minutes. I love how I see at this first table, she's already circling that words, those numbers that stand alone. I see people boxing the inequality symbols. Good job. What's the number when you can write this? Oh, no, not that one, this one. And then, how do you write the other part? With the. Yeah, come in. Come in, sit down. 1 more minute. I love that I see everybody has everyone that I've come across so far, they have their variable circled. Some people were extra brilliant and went to go do A as well. Good job. Perfect. I see some writing, some good writing things happening here. No, but it's okay. I keep that one. It's okay. I'm gonna show you. All right. So we are going to come back to the front. So as we did this, first of all, kudos to everybody that was doing all the annotation skills. I didn't even give you the CFS, but you knew the CFS. You had your variable circled. You had your number. Your variable circle, you had the number standing by itself. Some of y'all said, I don't like squiggly lines, I'm gonna do a straight line, and that's perfectly fine. Kudos to you too. So, one of the things I wanna point out here is that I saw people write 15 is less than or equal to T over 5 like that, right?
Yeah.
You are not going to see that, and I wanted to challenge you and I pushed you to write it in a different way. So then I saw people write this as T over 5, right? Which is good, that's perfectly fine. Then I saw somebody write this as like that, right? So here's the thing, you are going to see it, you're not gonna see it this way, right? I'm not ever gonna write that. You won't see that on the test. It won't populate that way in algebra, but you will see it written this way. So I do want to actually note that, and it's perfectly fine. So if you wrote it this way, no bueno, you still understand, you get the gist of it. Just make sure we have the actual fraction, and then we use the division symbol. You can use either or, doesn't matter. Okay? All right. And so for the second time, I'm gonna push us to key point 2. All right. Any questions? I'm about to say, Keith Durant, you have a question?
No, ma'am.
Okay, he looked like he had a question. That's the boss guy. So anywho, for a key point, now let's move into key point 2. So now we have, well, we've been doing this, we were actually looking at these graphs and we've been writing, right, the inequalities. Then we looked at these words, right, these phrases, mathematical sentences, and we said, hey, let's go ahead and let's write what that inequality will be. Now we're gonna figure out what does it mean to check to see if something is a solution when it comes to inequalities. This is something that you are going to have to do, and it is going to be important when you get to the latter units and we get to graphing inequalities. You're definitely gonna need to know how to check your solutions, okay? So, first things first, can I get somebody to read the key point 2 and all the way up until called us? Go ahead.
A solution of an inequality is a value that makes the inequality true. The set of all solutions that makes an inequality true is called a
Solution set. There we go. Thank you so much for reading that. Right? So, to have a solution to an inequality, right, it is going to be those values in which that make that inequality true, right? And so we get into the situation where for inequalities, you can have 3 different types of solutions, right? You can have one solution, so I want us to underline that. One solution. You can have multiple solutions, right? Or we get to the point where it's no bueno and you have no solution, all right? If it's no bueno, it's no solution, all right? So what does that look like? So let's go to this example down here, right? The directions tell us to tell whether -4 is a solution to the inequality, okay? So, and what's not on here is to justify your answer by showing work, and that's what we're gonna do. So first thing I think about is I have this inequality, x plus 8 is less than -3. The problem is asking us, is -4 a solution? Which means that technically I need to plug in a value for x, right? They told me that it's -4. So in my head, the first thing I'm going to do is note over here that x is equal to -4 because that's what they told us to plug in for the problem, okay? Now, here, I am going to plug in for x, just gonna plug in -4. So now I have -4 plus 8 is less than -3, right? So now let's do some math, right? -4 plus 8, right? What do we get when we do that? 4, okay? 4, and then we have 4 is less than -3. So now it's like flag on the play, like this don't make sense. 4 less than -3? No, that don't make sense. So because we know that 4 is not, I'm gonna put an X here, right? And that X lets me know that's not true, right? What is missing here, and normally we are accustomed to seeing this not equal to, it's gonna be the same thing here, we're just gonna put a little line through it, right? That's not, these two things are not equal to each other. That doesn't make sense, right? 4 is not less than -3, so this inequality statement is not actually true. Well, 4, and what is actually needed is that -4 is not a solution, right? And so you do all of this work, this is us justifying our answer. Essentially, this is not enough to give you your credit. What is needed is a sentence. And so what I want everybody to make sure that they put down here is -4 is not a solution, okay? After all of the work that you did, if you don't make that statement, then it's no bueno, because that's exactly what they're trying to, that's what they want. They want to know, is it a solution or is it not a solution? You could have done that, but if you don't actually state it, then we don't necessarily know, okay? All right. Why would -4 not be a solution? Because when I plug it into the inequality, I get that 4 is less than negative 3. That's not true. There's no point now. Yes, ma'am.
There's 4 is less than negative 3, but we were working with negative 4.
Yes, so we were working with negative 4. So what happens is, right, you are plugging in negative 4 for x. So when you plug in negative 4 for x, right, negative 4 plus a, you have to simplify that inequality and you get 4. That's a good question. Thank you for that. All right, any other questions? All right, so let's walk through this next one together. We have negative 4.5, x is greater than negative 21. First thing I need to do is write x is equal to negative 4. So what would I do next?
Plug it up.
What am I plugging in?
Negative 4.
And I'm plugging in negative 4 for what? Good job. All right. So negative 4.5 times negative 4 is going to be greater than negative 21. Okay? Now listen. I see somebody who pulled out their phone for a calculator. I'm not mad at it because Keith DeRosa has the calculator. But if we do the calculations here, I'll just give you the answer. We end up with 18. Okay? All right. So 18 is going to be greater than negative 21. All right.
Flag on the play.
She said flag on the play. Okay, let's do this. Is 18 greater than 21? Give me a thumbs up if you think it is. Give me a thumbs down if you think it's not. You can't give me in the middle. So, all right, I see some thumbs up. Thumbs up or thumbs down? All right, I see a lot of thumbs up. Okay, all right. Can somebody tell me why let me ask you this question. Is negative 4 a solution to this inequality? Yes, a one per, go ahead, yeah.
Yes, because 18 is positive and negative 21 would mean that the 18 is greater than negative 21.
Good job. All right, so now what am I missing? And actually, here's the thing. I got a nice little check that should go right here because it is going to be, right? That's correct. So what am I missing?
My sentence.
All right, what's my mathematical sentence?
Negative 4 is a solution.
Perfecto. Good job, y'all. Negative 4 is a solution. All right? So, when we have these problems and they come up, first thing we need to do is identify what our variable is. What are we plugging in, right? So, it was x is equal to negative 4 here. Oh, 1 second. Then we're going to plug it in, see if our statements make sense, and if they do, check. If not, it's an x, and give us a statement. Yes, ma'am.
So my math teacher last year told me that if I multiply or divide by a negative, that I'm supposed to flip the sign. So why didn't I flip the sign this time?
So yeah. Okay, so somebody wants to give it. Look, go ahead, explain it.
You're just substituting, you're not solving inequality.
Yeah, remember today we're not solving. When we're solving inequality, inequalities, and we multiply or divide by negative, we flip, but we're not multiplying or dividing anything, we're just simplifying on both sides. That is actually a very good question. All right, listen, the instructional leaders are cheaters today, but it's okay. I love you. All right, so now we're gonna do CFU number 2. You guys are gonna have 4 minutes to do this, and you are going to work with a partner. As you are doing CFU number 2, I am coming around and I am looking to see that you have your variable equal to whatever you're supposed to be solving for. I'm also coming around and I'm looking to see if you have a check, an X, and lastly a sentence, okay? Go ahead and go. You should be working with your partners. 4 minutes.
So that's the same thing that they taught yesterday about the MBT.
All right, you guys, I love this. I love that I see everybody writing their variable. Y'all, make sure you pay attention to the variable. Every variable is not X. We like X, but every variable is not X. We like X, but it's not always X.
Can I just walk in?
So,
Yeah, so they'll have a copy of that, so if you can,
You just spent the time on it.
so for geometry, they kind of do people.
So what if it goes way too flexible, if there's a student that makes a mistake? And so
There's a map for the picture that you need to.
I was a tutor in college, so.
Okay. Okay, that's negative.
Yeah, so it's the
I like that. I like the chocolate. Right. She said, I'm not doing the check for X, I'm just gonna go down the truth. Yeah. I like that.
I have a layout for the shit. Right. I unfortunately did not get it.
Alright, well, 1 minute. Everybody should almost be done with their problem. 1 minute. Alright, so I'm gonna bring us together since I think almost everybody is done. Can I get your eyes to the front in 5, 4, 3, 2. Alright, we're gonna stay at 2. Almost. Alright, perfect. So I did wanna just make sure that I put the answers up here for you all to be able to see. This is my answer, so don't try to cheat and go find my paper and come take this when I'm not looking, okay? But this is what we have. So check your answers and make sure you have it. Remember, I did want to point out, I walked around and I stated this as I was circulating. I saw people put in like x equals -6, x equals. Remember that in these variables, in these inequalities, the variables are different. So some were C, some were M, right? And I don't want us to ever lose points when we have our exams, okay? All right, any questions? Okay, there we go. All right. So now we are about to switch. We're about to go back and we're going to explore again, right? So in the first explore, you were given words and they asked you to graph, right? So now here, and everybody should be able to do this a little bit quickly, right? A little bit quicker because we have more knowledge. You are going to work with a partner and you're going to write an inequality for each one of these graphs. And so when in doing that, you are going to then in words describe all values of x that make the inequality true. So again, you're going to work with your partner. You are going to look at the graph, write your inequality, and then in words tell me what values of x make this true. Okay? What values of x would make this true? Okay? All right, you have 4 minutes. Go. Yeah, I got it. Timer. There we go. Expectation. So I know that we're adults and we're in here, but we are still in student mode, so I want to make sure that we have our cell phones away. So if you do have your cell phones, make sure you put those away. If it's one of those things that you need to address, you can step outside and then you can come back in to make sure that you are here. So thank you to everybody who are putting those things away. Definitely appreciate it. Now, here again, I know it's a little difficult to think about what the heck are these words that they're asking us for, but it's all numbers greater than or equal to 1. It's a variety of ways in which you could have said this. I know at table 3, he used the infinity symbol. I'm not mad at the infinity symbol because it's easier. So he thought about it in that way. So this is just here to get us thinking about what in the world, like what would those solutions be? How do you write those things, okay? So thank you to everybody for engaging in that. And we're gonna go ahead and push forward. to the, we're almost at the end, we're gonna push forward, okay? So key point 3 states that the solution set to any inequality, right, we were just talking about solution sets, right? The solution set to any inequality can be represented on a number line by a line whose starting point is an open or a closed circle, right? Somebody's gonna have an open or a closed circle, and that is going to be my starting point. A closed circle, right? The closed is, I always use it as a closed circle, and I state that. You may see it as a field because here on the picture, it's a little bit different, but you can say field as well. It's the same thing. A field circle means that the starting point is part of the solution set, right? Part of the solution set, right? So it's included. That was back in, remember the first engage? We all knew this 3 had to be a solution because it was included in the solution set, right? So thinking back to what we've done before, we're gonna tie it back in now, right? So now it says an open or an unfilled, I'll put it here, circle means that the starting point is not part of the solution, right? Now I'm gonna just keep on bringing us back to Jasmine, where 12 is not a part of our solution, right? Thinking of that. So we already know, and we've seen it, and I think it was Miss Hester, when she was graphing her inequalities in one of the explorers, when we had the greater than or equal to or less than or equal to, she used a closed circle or a filled circle because that was a part of the solution set, right? And then if we have an unfilled circle, it looks like this, right? Just looks just like this. That means that it's not a part of our solution set. So anytime we're graphing our inequalities, right, similar to like we see here, greater than or less than, we have these open circles. They're not a part of the solution, right? 6, 7, and 8 might be a part of the solution here, but 5 is not, right? And again, anytime we have those closed circles that look like this, or where it's filled, that means that it is a part of our solution. That number is going to be a part of it. So if I look here, 3 is a part of my solution. I have a closed fifth. 5 is a part of my solution. Why? Because the circle is closed or it is filled, okay? Now let's go, well, any questions on this? Keith DeRosa has a question.
Okay, and I think this is just the like pure mathematician in my heart here. I've an objection to the way you filled in the first blank. The solution set to an inequality can be represented on a number line by a line whose starting point is a closed circle.
We don't call it right?
Yeah, what's the issue with that?
Line is infinite in both directions.
Line's
Yes.
gonna be infinite in both directions.
Yes, array.
By array.
So a better word to use here would be ray.
Array, yeah.
Yeah.
There you go.
And in the second blank,
Let me-
above where you have closed, it's an open circle.
She's just documenting right below.
Oh, my confusion.
It's a lag. Am I missing something?
No, I was looking at where you hand wrote the word closed and you had an open circle above it.
Oh yeah, sorry. No. Open close, sorry. Okay, so now we have our geometry. We got the geometry vocab that we'll get later on in the year. I love geometry. I figured it out. I was like, array? Okay, so it's definitely going to be represented by array. And again, sorry for the misconception. So we have that, but we do have it. We have the key point of, we have our closed circles, the number is going to be included in our solution set. If we have our open circles, it's not going to be included. You got to get out. You're not invited to the party. All right, so now let's move on. Again, we're almost done, friends. Let's go to example number 3. What we are going to do here is we're going to graph the inequalities, okay? So we've done a little bit of writing, we did a little bit of graphing. Now we're going to actually graph these inequalities, and so we're just going to transition a little bit and then go back to writing. So here I have the first inequality for A is that y is less than or equal to -3. So here's the thing. Everybody, I just want to name this. What is important here is your circle, right? What kind of circle you have and what direction in which that ray, I'm gonna say it correctly, what direction in which it's actually going, okay? So on our papers, and it's not on here, it would have been if it was a different situation. On our paper right here, what I want us to write right here are these 3 letters that say CFS. This is going to be our criteria for success, right? So whenever we are graphing an inequality, right, the first thing that we are going to need is a number line, okay? The second thing we are going to need is going to be an open or a closed circle. And the last thing that we are absolutely going to need is the direction, right? Your direction is either going to go this way or that way, right? So 3 big things when we are graphing the inequality. So I want us to keep that in mind when we're doing this. So first things first, let's look at A. Y is less than or equal to -3. So the first thing I need to do is I need to draw a number line. Right? Now, am I somebody who's going to make these very nice, tick marks? Yes. Does it need to look that way? No. I am somebody who literally, I know I want to start here. I have 0. I can put 5 here. I can put -3 here. I just need 3 numbers, typically, right? If you have to be one of those people who's like, I want it to be perfect, that's fine, okay? So I have my number line. The second thing I need to do is I need to put a circle on here, right? What's my starting point? My starting point is at -3. I need to think, what kind of inequality symbol am I going to use? So I know somebody in here is so bright and can tell me which inequality symbol, which type of circle would I actually have here? Go ahead. A closed circle, right? So let's go ahead and put a closed circle, and I'm going to do that in yellow. Closed circle, and then I have to identify the direction of my graph. Am I going to shade and make it go everything to the left? I'm going to shade and everything's going to go to the right. So if it's left, then everything should go which way? To the left, okay? To the left, to the left. That's what we're going to do, all right? So that is as simple as this, okay? I'm going to do one more with you all, and then you are going to practice, okay? So for B is one of those problems that I look at and I go, what is going on here? Okay, what is going on here? So I have that 2 is less than X, right? Whenever I see that, I'm like, all right, I know that when I have my number line, I'm going to have all of my numbers that are going to be, 2 is less than X. That in my head doesn't make a little sense to me, and so what I'm going to do is I'm going to rewrite this, and I'm going to flip it so that way my variable is on the right side. And so here I'm going to rewrite this as X is greater than 2. Okay? So again, when we go from here, when I read this, I can read this as X is greater than 2 or 2 is less than X, right? It's the exact same thing. But I'm going to flip it, and I'm going to put my X on the left-hand side because that makes more sense for me in my head. In my head, this is what makes the most sense, okay? So now I'm going to do the first thing, which is to draw a number line. So let's draw a number line. 0, 6, -6, 6, okay? Right? I'm actually put the 2 here so that way we don't get confused. All right, so now I'm going to think about, is this going to be an open or closed circle? So show me with your hands, is this going to be an open circle or a closed circle? All right, listen, he's back there like this. All right. Good job, y'all. So we're going to have an open circle, and then because it's greater than, I'm going to shade everything to the right. Good job. There we go. Okay. All right, now. So again, before we move, if you have any questions, and before I move forward, I'm gonna answer any questions. Got one?
Should be unopened.
Dang it. Okay, let me do it this way. You're right. Snap. Sorry, I got tied up with the drawing. Sorry. It is open. Thank you. All right. Any other? And then Mario, make sure table 3 gets those points because you definitely are smarter than Miss Peters. So congratulations to you because I made a mistake. All right. Any other questions? Again, I want to note, I don't think you have any. When you get to the CFU, please do not try to make perfect lines with a bunch of tick marks. That's not important. What's important is, do you have your circle open or closed? Do you have the correct direction? Okay? All right, flip to page 6, and you all are going to do A and B. You are going to do A and B only, and you are going to have 2 minutes, all right? And you can work with a partner or you can do this one independently. I love how everybody's to the front. Thank you. We're gonna wait on table 5 and 6. All right, thank you. So we have done some exploring, and if I just want to go back and think about The objectives for today was to be able to determine the solutions that make the inequality true, right? Graph the solution set of inequalities, and then we were supposed to write these inequalities for both mathematical and real world problems. So we've done mathematicals, we have not done real world, and this is the last part, right? I do want to stamp that this is the most important part right here. This is that like meat and potatoes that we definitely need to get to, because of the fact that as we matriculate and we go through and we build on what we're learning in Algebra 1, you are not going to get away from word problems. You just don't get away from them, right? And so we have to take our knowledge and we think about how do we translate, like we did, the words into mathematical statements, right? And then now let's do the same thing just with a real world example, okay? So it looks scary at times. A lot of times I know when we see them, we try to shy away from them, but we're not going to do that because we're going to actually, we're going to push ourselves and we're going to, you know, we're going to excel here, okay? And just remember, we are in competition with them across the hall. We're better than them, okay? All right. So here we are going to write these inequalities from a graph, and this is a real world example, right? So it says the graph shows the height restrictions H in inches for 2 rides at an amusement park, and you are going to write an inequality that represents the height restrictions for each ride. And so here's the thing: anybody ever been to the amusement? Now, I'm little. Most of y'all are not that tiny, but you go to the amusement park, you think you're gonna get on a ride, and they like, listen, you're a little too small, you can't get on the ride. They make you stand up there, and it's like, it's embarrassing because you can't get on the ride because you're either too short, or there are some situations where you may be a little too tall to get on this ride for safety reasons, right? So this is what we got going on in this problem. We're at an amusement park, and we got to 2 rides, and they have some height restrictions, okay? So the graph is telling us that the height restrictions, when we write our inequalities, remember we circle our variables, we are going to represent that with the variable h. The units for this problem is inches, okay? So as I look through this, right, I have 2 rides, ride A, ride B. I'm gonna start with ride A. When I look at ride A, this is the graph that I am presented with, right? So again, if I think about it, if I work a little bit backwards from the CFS that I just gave us, right? If I say, okay, I have a number line. First of all, what's my variable? H, right? Do I have an open or a closed circle here? It's closed, right? And so then I think about the direction. Literally is the CFS we just did, right? This direction, everything is going to the right, which means that my inequality symbol should be greater than or equal to, right? So now I'm going to write the inequality that the height has to be greater than or equal to 48. Remember, I told you as we write these things, you have to have your units. So behind that, I'm going to just go ahead and put IN because that represents the inches, okay? Now, for ride B, if I look at this graph, I know I have my variable H. I have an open circle at 52, right? If I have an open circle at 52, that means that it's either going to be greater than or less than, right? The graph is going to the left, which means that my solutions are less than 52, and I'm going to add my inches, right? Now, here is where we're going to push, right? Because there's nothing else on this paper. This looks like it is ideal, which it is ideal. That's what they asked you. They asked you to write the inequality. The push here is, what does it mean? I wrote it, what does it mean? Okay, and what does H is greater than or equal to 48 inches? In this context, what does this even mean? Can somebody raise a silent hand and let me know, what do you think this means? Now, I heard from you 3 a lot today. Let me hear from somebody I haven't heard from. What do you think that means? And then guess what? It's okay if it's not, doesn't have to be perfect. What do you think it means? Go ahead.
If I'm 48 inches tall, I can get on the ride, and if I'm taller than 52 inches, I'm still cool. So it gives me the idea of like, I can't be shorter than 48 inches to ride this ride.
Okay, so now let me start here. For ride A specifically, right? Can you give me a sentence to describe this? I know you lumped it together, but it's okay. So let's start with ride A. Can you give me a sentence to describe that situation?
If you are 48 inches or taller, you may ride this ride.
Oh, you know what? I mean, y'all give her some snaps, because I mean, that's as simple as it is. So let's go ahead and write a sentence here, because I want us to be able to like really explain what this means. So she literally said, if you are 48 inches or she said higher but taller, you can get on the ride. So I'm going to say that. For ride A, if you are 48 inches or taller, you can get on the ride. That's as simple as that. Thank you so much for that. Now, can I get another brave soul to give me the explanation for ride B? Somebody I haven't heard from. What would be our explanation for ride B?
And I'm gonna call on you because you're right in front of me, but it's okay, I don't have your name.
Yes, ma'am.
Sorry. So ride B is saying if you are under 52 inches, you can get on the ride.
Okay, could you get on the ride if you were 52 inches? Okay, there we go, good job. So she said for ride B, if you are under 52 inches, you can get on the ride. There you go. Look at that. Can we get some snaps from Ms. Mello? Thank you so much. So again, I want us to think about in Algebra 1, we are pushing our writing skills, right? And here, you don't have to get it perfect. It doesn't have to really like sound, be very neat. It was as simple as if you are 48 inches or taller, you can get on the ride, right? And so this is what we're gonna have to do on our formative assessments. This is what we're gonna have to do on our summative assessments, and we are definitely gonna have to describe on that common assessment. So I wanted to just make sure I was able to show us how we can go from, we went from a graph, we wrote a mathematical sentence, and then we further explained that in words, and we were writing in math, okay? So I know we think we only write in English, okay, in science and social studies, but we write in math as well, okay? So due to our time constraints, y'all are not gonna get to your exit ticket. Y'all gonna clap for that? We're not gonna get to exit ticket, but for the remainder of this time, what I want you all to do, you're gonna go to the elaborate section. So we have 9 minutes. You are going to work in groups, and so I do wanna point out what the problems are for you. If you see right here, you see this icon that says writing, it's delayed, but that's okay. The icon that says writing in math, you are going to do an error analysis. So again, similar to how we were writing on the problem before, you are going to describe, figure out what the error is and describe what that error is and the correct solution here. And then the remainder of the problems, you have word problems, and then we have more practicing with graphing, okay? I am going to be working with individual people during this time, but you all are feel free to work at your table with your groups if you would like to, okay? If you want to work by yourself, you solo dolo, that's fine too, okay? So now we have 8 minutes to do that, and you are free to release and work on the elaborate section. Go.